Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm just going to talk about buffers that contain a base and its conjugate acid. So in my other videos up until now we've been really assuming that the buffer has an acid with its conjugate base. But what about if you have buffers with a base and its conjugate acid? Well, nothing really changes. The buffers work exactly the same way. The way you solve the problem is the same way. It's just whatever species you have, what your acid and bases are going to be different. So just to remind ourselves, so we were talking about buffers that have an acid conjugate base combo. So generically, it would look like this, where you have some weak acid reacts with water, and that's going to form H plus concentration, and you have your weak conjugate base, right? So you have your conjugate base here, and so this a buffer with these species would have, like, for example, 0.100 molar of your acid and maybe 0.100 molar of your conjugate base. And so these are the species that are involved in your acid base buffer. So, but you could also have a buffer that has a base with its conjugate acid. So the equation would look different here. So you have some sort of base, you throw it in the water. Water, it's going to react with water, take a hydrogen from the water, and you get OH minus concentration. But again, for your buffer, you're looking at the concentrations of base and conjugate acid. So this would be your base. This would be the conjugate acid. And so here you're looking at what is the concentrations. So here you would have 0.100 molar of your base and 0.100 molar of your conjugate acid. And so again, it works the same here, but again, the species are different. And so here would be an example of where you might have a buffer with a base and its conjugate acid, and that would be with ammonia and ammonium. So if I had, let me write this down. So that would be like having a 0.100 molar concentration of ammonia along with having a 0.100 molar concentration of ammonium mixed in together. And so here would be an example of where you would have a buffer that had a base with its conjugate acid. And so it would work the same way, the way you solve the problem. However, there is a slight difference, because remember, if you're going to use the Henderson-Hasselbalch equation, you need the pKa. And so along with the reaction of the weak base, if you have a weak base equation here for your buffer, it's going to come with a Kb. So you're going to need to find the Ka of this in order to use the Henderson-Hasselbalch equation. And so here you would use the Ka is this equation here. So Ka multiplied by Kb gives you Kw. So we know that Kw, of course, is 1.0 times 10 to the negative 14. So if you know the Kb, then you can find the Ka and use that in the Henderson-Hasselbalch equation as well. So I hope this is helpful. If you like this video, please like this video, hit that like button there. If I helped you clarify anything, please, again, like my video, subscribe to my channel, make sure you hit that subscribe button up there, somewhere up there, and so that way you can be notified by other videos I put out. Please put a comment down in the comment section. Let me know what you think, or if you have any questions or comments. Thanks for joining me. Have a great day.